Why, hello there. This is my math project, where I have to do 5 problems. This is the introduction. Yay! Hello there. Question 1. Suppose you have been assigned the job to measure the height of a farmer's silo. Climbing makes you dizzy, so you decide to do the whole job at ground level. From a point of 47.3 meters from the base of the silo, you find that you must look up at an angle of 53 degrees to see the top of the silo. How high is the tower? First, we have to make our triangle. And we draw the silo where we're finding the height of. So that'd be x. We are looking at it at a distance of 47.3 meters. And this is the angle we're looking at is theta. Theta is 53 degrees. Since we're trying to find the opposite and the known side of the triangle is adjacent, we're solving for tangent. Tangent is opposite over adjacent, and then we plug this in. Tangent theta equals opposite over adjacent. We get tangent 53 degrees equals x over 47.3 meters. Now, we have to get x on a single side of the equation to solve. So we multiply both sides by 47.3 meters to get 47.3 times tangent 53 equals x. And when we plug this into a calculator, we get 62.769 meters. And we round that up to 62.8 meters, which is the height of the silo. Question 2. Your cat is trapped on a tree branch 6.5 meters above the ground. You find a ladder that is only 6.7 meters long. If you want the ladder's tip on the branch, what angle will the ladder make with the ground? First, we have to get our tree. So we get the big fluffy leaves and then the tree part. So it's 6.5 meters above the ground. Now, we have to make the ladder. It's just gonna be this. Yeah. And it's 6.7 meters long. What we're trying to find is angle, or also known as theta. Since we have the opposite and we have the hypotenuse, we would do sine theta equals opposite, which is 6.5 meters, over hypotenuse, which is 6.7 meters. And to solve for theta, we have to take the inverse of sine, which would be 6.5 over 6.7, and that would equal theta. And so what we do is we enter this into the calculator. Inverse of sine, which is 6.5 over 6.7, and equals, for theta equals 75.96, and when we round that up, we get theta equals 76 degrees, which is our answer. Question 3. Haleakala is 10,000 feet high dormant volcano on Maui, Hawaii. The peak is a horizontal distance of only 30,000 feet from the ocean. At what angle would you have to look up to see the peak if you were standing on the beach? Okay, this is part A. So, for this, we have to, of course, draw our angle. Draw our triangle. So, it is 10,000 feet tall and 30,000 feet long. What we're looking for is the angle, or theta. Since we have opposite and adjacent, we have tangent theta equals, and our opposite is 10,000 over 30,000. And now we have to get the inverse. Tangent, the inverse of tangent, 10,000 over 30,000 equals theta, what we're looking for. So when we input this into the calculator, inverse of tangent, 10 over 30,000, we get an angle of 18.4 degrees. Question 3, part B. What is the straight line distance from the beach to the peak? So first, we will redraw our triangle. The mountain is 10,000 feet tall and 30,000 feet from the beach. What we're looking for is a straight line distance, or also known as the hypotenuse. To do this, we will simply do Pythagorean's theorem, which is a squared plus b squared equals c squared. To get 10,000 squared plus 30,000 squared equals our x squared. Now, x squared equals 1 billion. And so what we have to do is we have to find the square root of 1 billion to get our x. And the square root of 1 billion it equals roughly, because square roots are irrational, equals roughly 31,622.8 feet, which is our answer of the straight line distance from the beach to the peak. Question 4. An observer is 5.2 kilometers from a launch pad, observes a missile ascending. At a particular time, the angle of elevation is 34 degrees. Part A. How high is the missile? So first, we of course draw our triangle. We are looking for the height of the missile. And we get 5.2 kilometers away from the observer. And the angle he is looking at, theta, is 34 degrees. To solve for x, we use tangent because we have the opposite and we have the adjacent. So it would be tangent 34 degrees equals opposite x over adjacent 5.2 kilometers. To get x by itself, multiply both sides by 5.2, getting 5.2 times tangent 34 equals x. When plugging this into the calculator, we get x equals 3.5 kilometers, making our answer 3.5 kilometers in height. Question 4, part B. How far is the missile from the observer? For this, we redraw the triangle. We have the missile 3.5 kilometers above the ground, and it is 5.2 kilometers away from the observer. To find the distance between the missile and the observer, we have to solve for x using the Pythagorean theorem. For this, we get 3.5 0.5 squared plus 5.2 squared equals x squared. When we use this, x squared equals 39.29 kilometers. And to get what x equals, we have to find the square roots of both sides. The square root of 39.29 is 6.268. And when we round that, we get 6.3 kilometers away from the observer. Question 5. A team is building a zip line through the skyline of Atlanta. They have 125 feet of steel cable for the zip line and have been told the maximum angle of decline can only be 42 degrees. What is the maximum distance the two buildings can be apart? Okay, first we draw our triangle, where the zip line is the hypotenuse, and it is 125 feet. But the angle of decline, this is the angle of decline, 42 degrees. Due to the alternate interior angles theorem, this angle up here and this angle down here are the exact same. So they are both 42 degrees. What we solve for is x, which is the distance between the two buildings. And so, since we have the hypotenuse and the adjacent of the angle, we get cosine 42 degrees equals adjacent over hypotenuse, x over 125. Multiplying both sides by 125, you get x by itself. So you get 125 times cosine 42 equals x. And now, when you input this into the calculator, you get x equals 92.89 feet, or rounded to 92.9 feet, which is your answer.